guys, welcome back to Dragon Exotics, and today we will be discussing tortoise genetics. It's a pretty fun topic. I personally like it. We'll be utilizing the Punnett Square method, so I'll be drawing on my handy dandy whiteboard to help illustrate the concept to you guys. And if you already are familiar with the Punnett Square, you should be able to follow along even better. Behind us we have Sinky, my female, hopefully, female 5-year-old Sulcata tortoise. Next to her, we have Squash, the albino Sulcata tortoise. Don't worry guys, you'll be getting close-ups on all of these. And, we're gonna move you back, and new to this channel, we have a unexpected guest who I was gifted at one of the last reptile expos. We have Bruno, and Bruno is a 100% heterozygous for albino Sulcata tortoise. He's just a little baby. He's only about 2 months old, and we're gonna put him here. So before I start the video, as I mentioned, the types we have today are the wild type, the albino, and the het for albino. We're gonna be going over those in a bit of detail before we start our Punnett Square. But because when you keep tortoises, you wanna focus on their safety. Don't ever just leave them unsupervised on the table when you're not constantly watching them, because they can wander off. If I wasn't watching him, he'd probably wander off and accidentally fall. So for safety, not too worried about Sinky, but if she gets active, I'm gonna put her on the ground. But for these two, because they are very active, we're going to be giving them a bath in this video. So I have my handy dandy little tray that we are going to be putting up here for safety, and I'm going to pour some warm water into the tray. Just gonna get that all in there. There we are. It's an easy way to give your little tortoises a bath. You only want it to cover about the bottom of their shell. You don't want them to be fully underwater because you want them to breathe. So it's important to note. So let's get started. Now I'm going to be showing close-up clips in this section right here of the video. We'll have a nice little box of the close-ups of what each of these morphs or types of Sulcata tortoises look like. And there's certain genetics that play a role to make them look like this. So first we're gonna start with Sinky. And as I said, she is a wild type Sulcata tortoise. This means that she doesn't have any extra coloration besides what you'd normally find in a wild Sulcata tortoise. Note the brown head, the normal brownish, whitish legs. Then we have the typical brown to light coloration with a bit of black, a bit of those growth lines on the shell. We don't see any distinct red eyes, we don't see purple eyes, we don't really see anything too crazy. Just has a beautiful brown, maybe caramelish coloration to them. And I think that's great. Sinky is beautiful. So thank you, Sinky. Next, we'll have in, let's grab you just for a moment. Next, above that, we have the albino Sulcata tortoise, like Squash. Notice the red eyes and the yellow tinted skin, a bit white in some areas, especially in the growth lines. The legs itself are a pale color, a bit more yellow. But really when you think of albino, you're thinking of that whitish skin, maybe yellowish coloration with those bright red eyes. And that is what we're talking about when we talk about albinism. Our third little friend for today, and he is so active. I want to say he, because if we look at this little tail here, he has the longest tail that I have ever seen in a baby Sulcata. So maybe fingers crossed that he's he. So anyways, he is het for albino, and we're going to go into more detail on what this means, but I just want to show you on what a animal or tortoise looks like when they are het for albino. Het means heterozygous, and it is a carrier of that albino gene. And I promise we'll go more into this. But these tortoises, as seen in this video, they look like normal tortoises. They look like Sinky. When he grows up, he will look like Sinky. Now, all tortoises are unique, so they may have a little bit of variation on their shell, but they're not gonna be white with red eyes, the yellow coloration. They just aren't gonna look like that. They are going to look like a normal wild type sulcata, but they carry the albino gene that would make squash, or the yellow coloration for the albino tortoise. So we're gonna put him back. This is Bruno. And there you go, little dude. Have fun swimming. More like walking in water. I promise he's not swimming. I'll show you in a bit. So to get into this, we wanna look into what wild type looks like as far as genetics, what albino looks like as far as genetics, and what heterozygous looks like. So we're gonna focus on this whiteboard here. I'm gonna angle that a little bit. And we're just going to bring a little marker out if I can do this. We're gonna make a square. All right, and we're back. Okay, so I know this may look a little intimidating for those of you who don't know what the Punnett Square is, but I promise it helps us figure out reptile and tortoise genetics. So I put Sinky on the ground for her own safety. Remember not to leave a tortoise on a table because that can be dangerous. They can fall and crack their shell. So just be sure that you keep your tortoises on the ground. All right, so what we have here in this first diagram right here, is a dominant wild type. We have something like Sinky, okay? Sinky has no traits, no carrier, nothing for albinism, not ivory, nothing. So Sinky's normal. So Sinky is an AA. Let's say that we found her a boy sulcata who also was completely normal, looks normal, and does not carry any of those genes. So this is for wild type. That's the dominant trait. We're going to have A. We're just gonna write this out. A, and A. Okay? I know, sorry for the bad handwriting. So this, I mean, look at that, 100%. Oh, you can't see where I'm writing. Okay, geez, there's bugs. 100% of those would be wild type visual. And they would be A, okay? So if you bred a normal sulcata, not a carrier for albino, to a normal sulcata, not a carrier, it's obviously gonna be a normal sulcata. It's gonna look normal. Now, if you have a normal sulcata, so let's say Sinky is up here. If she's the mother, she is normal. She is AA. If I were to breed Sinky to Bruno, who is 100% heterozygous for the albino trait, so big A, little a is that albino trait. He looks normal, but he's a carrier for albinism. If we were to breed those two, we would just fill this out and we're just matching them across. So like this one goes to this one, then this one to this one to this one. You're just adding it together. And this one to this one, okay? Oh, I forgot about that. Okay, so if this was the case, 50% of those babies would have a chance of being het or heterozygous for albinism. 50% of those have the chance of, well, being the carrier of that albino trait. So they have a 50% chance of carrying that trait. So het for albino, but they are visual normal. They visually look normal. They look the same. They look normal. So Bruno looks exactly like Stinky, but because Bruno carries that albino gene, if he bred to Stinky, then 50% of the babies could be het for albino. To be clear, none of those babies would look albino. They just wouldn't. They have to have the complete recessive trait to look visually albino, meaning that little a needs to be in front. So let's go into this next one. Let's say that we'll stick with Bruno down here as the father, and he's 100% het for albino. Let's say we got another female and she's up here. That female is also 100% het for albino. If those mated together, we would get 3 different options. Get big A, so dominant, looks normal, doesn't carry anything. We'd get big A, which is heterozygous for albinism, and we get little a, okay? Notice how I said that little a is what's going to show that albino trait. So right here, notice how we have 3 choices, and 2 of those 3 are heterozygous for albinism, meaning there is going to be a 66% chance that it's going to be het for albino. Oh goodness, okay, there we go. Het for albino, okay? So there is a chance that some of those babies will be normal. They won't carry anything. They'll be like Stinky up here. There's also a chance they'll be regular. They'll look regular, but they'll be het for albino, so they'll look like Bruno, but they carry that albino gene. And then there's a chance that they will be albino. It's a very low chance, but it's possible if you bred a het albino tortoise to a het albino tortoise that you would get a chance of getting some albinos. And they would be visually albino, and they would carry the albino gene, little a. So let's take that and bring it here. Let's say we have Squash, and Squash is female. She is little a, because when they show that albino trait, they are considered little a, because that's the gene. So let's say that we bred Squash to Bruno, who is big A, because he's het for albino. We would get big A, little a, and little a. And based on that, all of those babies will at least carry the albino gene. So this would be, if it's not albino, it is 100% het for albino. So this is going to be 100% het right here, right there. So 100% het. Now, so those babies are either all going to look albino, or they are going to definitely be a carrier for albino. So let's switch this up. The last Punnett Square, I promise, because I know this is definitely a lot. I don't know where my rag went, but it's okay. So we're just gonna do this. Let's say we took this baby that was bred, the little a, so it's another albino, and we bred it to Squash. Now, this is albino. That would mean, based on our little Punnett Square, that everyone is 100, oh geez, okay, albino. There we go. So based on this, all of those babies would be albino. So I know this is a lot, but really the moral of the story is we have 3 types. We've got the dominant, we've got the, oh, you can't see that. Okay, you got the dominant right here. Then you have the heterozygous, and then you have the recessive gene for albino right there. So if you use a Punnett Square and you match everything up, you can technically get a general idea of what those tortoises may be if you breed them and you know where they came from, if you know if they're 100% het for albino, like if you know what's going on with their genetics. Now you can use the same chart for ivory and all those other morphs. Kind of just, you can use AA, but like if it's ivory, it's like big I, little I, it's however you want to do it. It's a dominant gene and a recessive gene, and that puts together what you're looking at. So hopefully that makes sense. If it doesn't, feel free to message me and I'll try to clear it up. Usually I'm a visual learner, so I like these squares because you can put it together. You know, dominant trait, dominant trait, dominant trait, heterozygous, like all of those. But I can definitely explain it in a different way if you guys don't understand.